Okay, so this is a continuation of our video on the law of conservation of mass. We saw that it is important for you to balance chemical equations so that you acknowledge that we do not create a new mass or destroy the original number of atoms that we had in the beginning. So we looked at this in the previous video. So if you are given the mass of sodium, which is 23 grams from the periodic table, if you multiply by the 2 there, we are saying that we have 2 atoms of sodium, and you add the 2 atoms of chlorine, which are 2 times our 35.5, you get a mass of 117, and this should balance out with the mass that you get for the 2 molecules of sodium chloride. So 2 times 23 plus 35.5. Okay, so you're going to have a relative molecular mass of 117, which balances out with the original mass that you started off with. So if you had a mass of 2.3 grams for sodium, this should react with exactly 3.5 grams of chlorine to give you 5.8 grams of sodium chloride. And this is because we assume here that all your reactants would have completely reacted to form the product sodium chloride. But in other cases, you'll see that this is not possible due to a number of factors. Your reactants may not be able to react completely, and in that case they are not going to give you the theoretical yield of 5.8 grams. You're going to get a lesser yield. For example, if I had 2.3 grams of sodium and the 3.5 grams chlorine, but I do not get exactly 5.8 grams due to a number of factors, which may be failure to collect the product properly, or due to the poor conditions that cause your reactants not to react completely. Suppose I get 4.5 grams instead of 5.8 grams, so the 4.5 grams is termed the actual yield. So this is compared with the theoretical yield, and we now have a new concept that is called percentage yield. So in order for you to get the percentage yield here, you're going to say the 4.5 grams that I got divided by the theoretical yield that I was supposed to get, which is 5.8, times 100, and you get your percentage yield. So you should remember this concept where we say the actual yield divided by the theoretical yield. Okay. So let's rush ahead. It should be known that generally when one of your reactants is a gas, then you are not going to get exactly the same masses for your reactants and your products. In other words, they are not going to balance out. Your mass will seem to increase, and this is seen in this example here of magnesium versus oxygen, which is coming from the atmosphere. This will give you a product with a slightly higher mass, which does not balance out with the mass that you begin with. So this is because one of our products here is a gas. But what we can do in order for the masses to balance out is to put them in a sealed container instead of reacting the two in open air where atmospheric air is in excess. We can seal the container, in which case the reactant's mass is going to balance out with our product's mass perfectly. So another example is when we have calcium carbonate there. We can heat calcium carbonate, group 2 carbonates, to form the metal oxides and carbon dioxide. It's an important concept as well for you to remember that when you heat group 2 carbonates, you're going to get the metal oxide and carbon dioxide gas. When you have such a reaction, when you measure the mass of the product, it may seem to decrease because our carbon dioxide is a gas which can float into the atmosphere. It can diffuse into the atmosphere, thus decreasing the mass of the product. So again, what we can do here is to simply react these in a sealed container, and when we do so, we will realize when we trap our carbon dioxide in a sealed container, we are going to see the mass of the reactants balancing out with the mass of the product. So the exceptions are there where your mass may seem to increase, where one of our reactants, we saw that it will be a gas, and that will exaggerate the mass of the product. When one of our products is a gas, then this will seem to decrease the mass of the product. And what we can do is react these in a sealed container in order for the masses to perfectly balance out. So remember those two exceptions. So we said here in summary, mass is always conserved in a chemical reaction. Our grams or the number of atoms should be conserved, and this is why we balance chemical equations. So we are going to look at our next concept, which is the concept of limiting reagents. So just remember these 2 points here, that if your mass seem to increase in the product, then one of your reactants should be a gas, is a gas. And if your mass seem to decrease, then one of your products is a gas. So I'll meet you in the next video.